able to attend. I had a number of emails from people who said that they wanted to attend, but they're not going to be able to until a certain time, or some people have to leave early and they wanted to know if I was going to record. So I am recording. Okay, so before we start, I just wanted to do a land acknowledgement that the ARPDC respectfully acknowledges that we are located on traditional lands across the province of Alberta and on Treaty 4, 6, 7, 8, and 10 territories, the traveling route, gathering place, and meeting grounds for Indigenous peoples, whose histories, languages, cultures, and traditions continue to influence our vibrant community. We are grateful for the traditional knowledge keepers and elders who are still with us today and those who have gone before us. We recognize the land as an act of reconciliation and gratitude to those whose territory we reside on or are visiting. So who am I? And my name is Yulana Seletsky, and I am a mom of 3 girls. And that picture there was taken by my beautiful niece, who's actually here today. It was taken at Thanksgiving. And I am a retired teacher from Greater St. Albert Catholic Schools. I worked for G Sacred since 1983 until I retired the year COVID started. I retired at Christmas, and then bang, COVID started right after that. So I was a happy retiree. But I've also been working for the Edmonton Regional Learning Consortia since 2006 as a PD provider. And I also do a little work here and there for Pearson Canada, Pearson Publishers, and I do a lot of just reviewing of their resources for mathematics. Since I've retired, I've taken up a bad habit of traveling. I love traveling, and on my last trip that we took, I actually swam with sharks. And so that was one of the highlights of my last trip, and that was in the French Polynesian. Life is good when you retire after working for close to 30 years. Trust me. Trust me. Those of you who are just new teachers, trust me, it is very rewarding. Okay, so before we start talking about anything to do with place value, what I want to talk about is the scope and sequence of actually the numbers. And we're talking about whole numbers first and decimal numbers. And you will see this scope and sequence goes from from kindergarten to grade 6. It is located in the ARPDC math resources. I'll give you a link to everything that I am sharing today, absolutely everything, slides included. And I just want to show you how it grows from kindergarten right up to grade 6. In kindergarten, we talk and we investigate quantities to 10. That's really a huge thing. That's really foundational for kids to understand how numbers to 10 work. And then they get to all of a sudden getting that 10 ones make 110. And then in grade 1, we talk about quantities to 100. And that's actually the very beginning of place value. And in grade 2, we get to work with numbers to 1,000. And that is really in grade 2, we work really hard on building that place value understanding. What are all the different ways that I can make the number 642? And then in grade 3, we go up to 100,000. And now you'll notice that, again, it is using place value understanding so that when they come to you in grade 4 to 6, they will already had a few years of place value understanding, so that when they start with the decimal place value understanding, it's just a carry on of what they already know. In and then in grade 4, what we work with is decimals, tenths, and hundredths. In grade 5, we go to 10 million and we talk about decimal place values to thousandths. And in grade 6, we assume they know it all. Right, Larissa? They got it. They've mastered it grade 6. And so we can go on to all other numbers now, like integers with them. And we know that doesn't work. We know that's not what has happened. And especially with curriculum, how it has shifted, your kids in grade 6 may have missed the stuff from grade 4 and 5. And so now you may find that they are behind, but that's okay, because if we teach place value correctly, then what you'll find is a really deep understanding of that place value will help them move along to the bigger numbers and to the smaller numbers when we talk about decimals. So again, in grade 4, we work with numbers to 10,000, including decimal numbers and to hundredths, and millions using decimal numbers to thousands. And again, in grade 6, we incorporate now money and metric measurement. And then also we talk about multiplication and division of decimal numbers also. You just need to know that multiplication and division grows. In grade 4, we do the basic facts up to 12 times 12, and we do 3-digit by 1 digit, and the effect of multiplying something by 10, 100, and 1,000. In grade 5, we do 3-digit by 2-digit and divide 3-digit by 1 digit. And then in grade 6, the only thing they need to really know how to do paper and pencil is divide a 3-digit number by 2 digits. So you're not going to be doing 4 or 5-digit numbers divided by 3-digit numbers. You don't have to go that far. It's just 3 by 2. Now, if you wanted to look at the new curriculum, and by the way, this is a continuation from Betty's session where Betty talked about the organizing ideas, the guiding questions, the learning outcome, and the cusps that center around these numbers. I'm not going to go through all of this per se, but I just wanted to show you there's a few things that you may not be aware of. Number one, the consultants at the ARPDC level, and Isabel is here, so she's one of the consultants that I'm talking about. We numbered all of the outcomes in the Alberta curriculum so that to make things easier for our teachers. And so if you were to go to the ARPDC resources, you'll find all of the outcomes. There's a document there with all the numbers that are numbered. So one of the outcomes is this one in particular, where students apply place value to decimal numbers. And the way we numbered it is the first number is the grade level. So this is grade 4. The strand, or the big picture is number, and it's the first outcome, and it's the first line of the first outcome. So then if you were to look here, you'll notice that there's the knowledge, what we have to know, what we have to understand, and the skills and procedures that we should be able to do with what we know. And so we want to make sure, first of all, from grade 4, that we know in our grade 4 to 6s, with our large numbers, we do not use commas. Okay, we do not use commas in those numbers because, number one, we are a bilingual country, and in French, the comma represents a decimal. And so when we use a comma in Alberta, it also means a decimal. Now, the other reason we don't use it is because we are a metric country, and none of the metric countries in the world use commas. And also, when we say whole numbers, we do not say the word and. So we don't, so for example, when we have the number 647, I don't go 640 and 7 or 647. Why? The and represents is a signal to our students that we're talking about a part of a whole number. So the and is where the word and is used to indicate a decimal point. So that's something that is right in the knowledge for grade 4. So I just want to make sure that we are all aware of that if we are even in grade 5 or 6. Now, one of the biggest problems with buying things from all the teacher stores, a lot of them, and especially Teacher Pay Teacher, a lot of those things come from the States, and the States will use commas. And that is the worst thing that we could do for our students, because we're sending real mixed messages. Now, the other thing that I want you to be aware of is anyone who was born in the 80s and further, even the 70s, 60s, like myself, a lot of things changed. And so when I was going to school, when we were reading numbers, we would always use the word and. When a lot of the parents of the students that you work with, they use commas when they're writing large numbers. So please be aware that you have to help them understand that also. Okay, and then so this is another outcome from grade 4. This is grade 4 N2, and it's the first outcome in it's the first line of the second outcome, and it is about adding and subtracting decimal numbers to hundreds, where we start to introduce standard algorithms. But I'm a person, and I'm sure that there's many of you out there that believe before we teach any algorithms, we want to make sure kids understand the numbers that they're working with. It's huge. Like, we don't just say line up the decimals and let's just add. We want them to be able to estimate. The biggest word that if I could go back to teaching, the number one thing I would change is, instead of solving for all these questions, I would say estimate for the answer. I know a lot of my students, what they would do when I say estimate, a lot of them would find the answer and then they round the answer. And that's not estimating. Estimating is where when you make an educated, an educated estimation so that you can check the reasonableness of your answer. Does my answer make sense? I'll never forget when I asked a student to go back to his desk because I wanted him to think about, does his answer make sense? And then he came back to me, he says, I don't know if my answer makes sense. How would I know that? And I thought, okay, good question. We have to talk about the reasonableness of answer. We need to talk about how big or how small numbers are first. Okay, and then we go into grade 5, where they analyze the patterns in place value, and we understand that there's a symmetry that rotates on the left and the right side of the ones place, not of the decimal place. That symmetry rotates infinitely to the left and the right of the ones place. We'll often have kids that'll think it rotates around the decimal point, and they call the first place after the decimal point a oneth.
A oneth.
And so if it's a oneth, really they don't understand. Okay, then in grade 5 also, they start adding and subtracting up to 1,000,000, including decimal numbers to thousandths. And they also include problems with money. And in grade 6 now, oh, I'm just going to shut off someone's mic here, because there we go. The addition and subtraction of numbers in problem-solving contexts is facilitated by standard algorithms. Now, in grade 6, you guys, before you get into that algorithm, it is so important that they actually understand the numbers that they're working with. So, and then people have often asked me, what is a standard algorithm? Well, I'm going to be very honest with you. All depends on where you grew up. There's so many different standard algorithms. And so if you're sending home homework and you have children that are from immigrant families, their algorithms are different than what you may have studied. And so there is not one standard algorithm. So we will talk about some ways of adding and subtracting after, but we will, for now, we're just moving on. Okay. And then also in grade 6, they do multiplication and division of decimal numbers. And I have a session that is specific to that concept at a later date. So first of all, in the chat, I'm going to do something that I call a waterfall effect. So what that means is I'm going to ask you a question, and I'd like you to put it into the chat. And then when I say enter or return, that's when you enter your answer. So when I say place value, what do you think of? What are you thinking of when I say, let's talk about place value? What is it? What is place value? What's the definition of place value for you? Like, what do you think? And please, one of the things I want to make sure everyone is aware of before they put anything down is I love mistakes. We learn by our mistakes. So don't worry if your answer is right or wrong. It doesn't matter. What do you think of when I say place value? So put it down into the chat, please. And press enter or return. Okay, how big or small a number, value of each digit, what numbers are worth, value, no value. Beautiful. Okay, now that's okay. I have to tell you, this is one of the first times that I didn't have someone say, I think of the place value chart. And that's great. It is, the definition is it's the place a digit is in will tell us the value of that digit. So it is not just the tens, the hundreds, the thousands, the 10,000s. It is the value of that digit because it depends on the place that's in. So it really is the value of the digit that of the number. So one of the things that we start off in kindergarten with is called unitizing. And what that is where we actually start that base 10 system so that we help kids in kindergarten grow from understanding when I have 10 ones, 10 ones is equal to 110. And then in grade 1, they go to and learn that 10 tens makes 100. And unitizing really requires that kids start using numbers to count objects and groups simultaneously. And that's a huge turn for kids. And so it's all, a lot of kids don't actually grasp it until later grades. Now you have to know, yeah, if they're in grade 4, they're already 3 years ahead of where they were in grade 1. If they miss that in grade 1, it should be an easy fix for you to help them. And so what we have is this base 10 thinking, and we use, for example, 10 frames. And so this number here is 53. And then I say, well, what if I empty some of my cards? How many dots do I have? Kids should be able to say, well, I still have 53. I have 53 is either 5 10s and 3 1s, or it could be 3 10s and 23 1s. So there's many different ways of making 53. Just like when they get to grade 2, we start talking about making those numbers in the hundreds. And so how many ways can you make 65? And so questions in grade 1, I have 6 10s, 5 1s. Well, I can also do 5 10s, 15 1s, or I can do 4 10s, 25 1s. So the key understanding to place value is that there's patterns in the way we say and write numbers, and that pattern will help us remember order. And so when we look at the place value charts that we have in our classroom, you will notice that there is a pattern to the numbers in each one of the major sections. In the ones, there's ones, tens, and hundreds. In the thousands, there's ones, tens, and hundreds. And in the millions, there's ones, tens, and hundreds. In the billions, there's ones, tens, and hundreds. And as soon as kids really get a solid grasp of that, it is a lot easier when we're working with larger numbers. And so, for example, the number 3,264, the 2 represents 200 because it is 2 times 100. The 6 is 60. It's not just a 6 that's in the tens. It is 6 that's in the tens, but the value is 60. And the place value of the 3 is 3,000. And so what we want kids to also know is there's a real multiplicative relationship between the places, that there's the value of these position increase in powers of 10 from right to left. So when we go from right to left, we multiply by 10. So 10 ones gives us 110. 10 tens gives us 100. 10 hundreds gives me 1,000. 10 thousands give me 10,000. 10 thousands will give me 100,000. And it just keeps on going. This is a pattern. It goes on indefinitely. But for every 2, or when we go the other way, when we're going from left to right, we're dividing by 10. And so please, when we tell kids, when you multiply by 10, just add a 0, please stop that, because when you start multiplying by decimals, you can't just add a 0. It will not change the value of that number. So that's a rule that expires. But anyway, when we do, so just going, like, for example, if I have 10 million and I divide by 10, I get a million. When I have 1 million divided by 10, I get 100,000. So the values change by powers of 10. And then if I'm going by 2 place values, I'm actually multiplying by 100. And so if I have a 10 and I multiply by 100, I get 1,000. And if I have 100 and multiply by 100, I get 10,000. And so what's happening is I'm moving it 2 place values. And the same thing is happening when I divide by 100. I am decreasing it by 100-fold. Okay. If I'm going too fast at any point, please stop me. So the key understanding for these kids is that they understand that there's a multiplicative relationship. And so if it goes up by tens, by hundreds, by thousands, by 10,000. And so I can multiply a 1 by 1,000 and I get 1,000. I multiply a 10 by 1,000, I get 10,000. I multiply 100 by 1,000 and I get 100,000. There's this real multiplicative thing, relationship. And I don't want kids to just say, okay, if I'm multiplying by 100, I just have to add 2 zeros. Or if I'm multiplying by 1,000, I multiply by 3 zeros. I add 3 zeros. That rule expires as soon as you start multiplying decimals. So this is something that we don't want to ever tell our students. Now, one of the things that I personally love, this place value chart here, I really like it because it doesn't have any commas. But then I saw this one come out from New Zealand that is my very favorite. It's called the place value houses. And the place value houses all starts off with the trendsetter house, where the trend, everything in the place value system is based on this trendsetter house, on the ones. And in the ones, we have the ones, the tens, and the hundreds. Then we get the thousands house. It also has the ones, the tens, and the hundreds. And then I have the millions house that has the ones, tens, and the hundreds. And I have the billions house that has the ones, tens, and hundreds. And then I have the trillions house that has the ones, tens, and hundreds. And so I have to tell you, I was in a classroom when I was still a consultant for St. Albert, and one of the teachers was using these houses. And she asked the students, well, what's the difference between the tens in each one of the houses? And one of the students put up their last their name, their hand, and said, their last name. What do you mean their last name? Well, in one house, it's just tens. In another house, it's the 10,000s. Then it's the 10 millions. Then it's the 10 billions. Then it's the 10. And I was standing there going, I love this. And I said, I am using this. Where did you find this? And she said it was on the New Zealand math, the New Zealand Board of Education, their thing. So I'm going to give you the link to that too, because if you wanted to use this is beautiful. And I'll show you why it was so beautiful, because what she did was she put a little sign on top that is the ones, the thousands, the millions, the billions, the trillions, just to make it more obvious. And she talked about that the key understanding is to understand how we read, write, and calculate with whole numbers. Place value is the key for all of that. So now, here's the example of what she wrote. She said, now, when she was doing this, my head was exploding, and I thought, I have to share this with as many teachers as I possibly can, because how many times do we say a number and kids don't even know how to write it? And so if you're asking them to say to do some calculations with a number, or if you're saying a number out loud, they don't have a clue of what that number actually looks like. So she said the number 5,036,407,004. And she asked the students to write it. And I thought, okay, first of all, you're not supposed to be going up to 1 billion in grade 5. And then, but I thought, oh my gosh, she's not doing anything with these numbers. All she's doing is making sure the kids know how to read, write, and say the number, which is a real key understanding. And I thought, all the power to her. And I watched, and she said, I'm going to say the number again. And as she's saying this number, I was walking around, and this is what I saw. She said 5 billion. And this is what I saw kids doing. 36 million. 407,000. 4. And then she said, so now what? And the kids said, well, you need to put placeholders. And what are placeholders? They said zeros. And what does that mean? It means there's no loose numbers. And I thought, this is brilliant. And so the kids went and filled that in with the zeros. And all of a sudden, they could write this number, and they had 5,036,407,004. And I thought to myself, this truly is amazing. Now, this is just one key understanding, read, write, and say, but it's a huge key understanding for kids working with these numbers. So also knowing, you need to know the difference between face value and place value. So for example, in the number 3,572, the face value of each of those digits is just the name of the digit, like 2753. That's just the face value. But the place value depends on where it is. The place value of the 2 is 2. The place value of the 7 is 70. The place value of 5 is 500. The place value of 3 is 3,000. Now notice it's not, the place value of 7 is not 10. The place value of 5 is not 100. The place value of 3 is not 1,000. That is where it is in the place value chart, but the place value of each digit is the digit multiplied by where it is in the place value chart. So if they're doing expanded form, 3,000 plus 500 plus 70 plus 2 is 3,572. Now, so is 2 plus 70 plus 500 plus 3,000. Now, when kids get a worksheet that has just this, they can get that answer by not understanding place value. A lot of them will just go 3,572 and they write the answer down. That's a real useless question to ask kids. I found that when I changed the question around and I was getting kids that said 2 plus, if they wrote 2753, I knew they had no idea what place out value was. If I mixed it up and I said 3,000 plus 70 plus 500 plus 2, now kids that don't understand that will just go left to right and write the digits in. So be careful how you ask questions to students. So for example, what I mean by that is this. I put a question up on the board that is this one here, 3,487. And we're going to do the waterfall effect again. Okay, so get ready. What digit is in the hundreds place? And go. Perfect. Question number 2. What is the place value of the 4? Beautiful. Ready? No, the place value is not hundreds. It is 400. It is in the hundreds place, but the place value is 400. So, ready for the last question? Don't go until I give everyone a chance to think about this question. How many hundreds do I have? Go. Okay. I do not have only 400s. I actually have 3,400s. And that is a huge understanding for teachers and students. Remember when we were working on the slides, how many ways can I make 52? The same thing goes here. How many ones do I have? How many ones do I have? Right, I have 3,487 ones. And so when I start grouping them so that I can count them, then I would have how many tens? 348 tens. which means I have 34 hundredths. How many thousands do I have? I would have 3. So please be very careful how you ask kids questions. What digit is in the hundredths place, or what is the place value of the digit? And you also should ask, how many hundreds do I have? How many tens do I have? How many ones do I have? So this is something I got out of a book written by Marion Small, which is just brilliant. And this is beautiful if you want to just go further into this activity. How does it help to think of 3,400 as 34 hundredths? Well, what she did was she asks this question. Rename 30,000 to make it easier to answer. So these questions. So for example, I don't know, many of you may have not been born at this time. I'm really dating myself. Well, we used to have a purple bill, and that purple bill used to be $1,000 bill. I never was fortunate enough in my life to touch it, but there used to be $1,000 bill. Now, if I went to the bank and I was to withdraw 30,000, I could ask my students how many $1,000 bills would they need to make this amount. And what I want my kids to say is, yeah, they would have to give you 30 bills, 30 $1,000 bills. Well, they don't make those $1,000 bills anymore. So if the teller is going to give me $100 bills, how many hundreds would she give me? Anybody? You bet. She would have to give me 300 $300 $100 bills for $30,000. Well, what if she only had $10 bills? How many of those would she have to give me? Exactly. She'd have to give me 3,000 $10 bills. And then what about loonies? That's a lot of loonies. 300,000. Of course, she would have to give us, you're right, a truckload. Okay, now in Marion Small's book, she also asks, how many different ways can the bank give you your $30,000? Now, what an absolutely phenomenal question to send home for homework, because that could be done, take them 8 hours to do. But you would say, okay, I don't want more than 10 answers, or I don't want more than 20 answers. But I do want you to think about how many different ways that you can make $30,000. Now, kids really need to have that idea about how many ways to make $420 before they get into the thousands and the 10,000. Okay, so this is another, this is a great little video I'm going to show you. It is how that thinking helps also with mental math.
Numeral expander. How can a numeral
Can you hear
expander
this?
foster number sense and thinking skills?
Numeral expanders are simple tools that can help students see numbers differently. For example, look at this number. If we expand the number like this, it helps us to read the number in the traditional way.
I see 317.
We can also expand the number to reveal each place name.
300ths, 110, and 7 ones.
This understanding is needed in order to write and solve algorithms. But the expander can help us think differently. What do you notice now?
Oh, 317 is also 31 tens and 7 ones.
Yes, and when we think this way, we don't need to regroup to solve this problem. How many tens in the first number?
31.
How many tens in the second number?
28.
What is 31 tens subtract 28 tens?
3 tens. And there are 2 ones remaining. Wow, that is so much easier.
Now, isn't that easier than regrouping all the time? There are some things that when we really understand place value and we understand, we can do math mentally a lot easier. So a key to understanding place value is the understanding of the relationship between places. Now, this book I picked up many years. Oops, I'm just going to skip forward here. Many years ago when I was a young teacher at Teachers Convention. And so all I did was I photocopied, and I'm using the pictures from the book. And no, this book is nowhere to be found. It was written by Michael McGuffey, and I just wish someone would print something like this again, because it's a beautiful book for students. So I placed it on slides, and I'm giving you all these slides that you can use if you want to help your kids understand the magnitude of numbers. So I want you to think carefully, because after this, I'm going to give you a question. So when we work with place value blocks, we call that little square a unit, and that's 1. When I multiply that by 10, I get a 10 rod, and that is 10 ones or 110. Now, if I take the 10 rods and multiply them by 10, I get 100, and I call that a flat. And so the flat has 10 rods or 100 ones in it, right? Does that make sense? Now, multiply that by 10, and I get 1,000. So that cube has 10 flats in it, or it has 100 rods, or it has 1,000 cubes, or if I want to use mathematical language, that 1,000 has 10 hundredths, or 100 tens, or 1,000 ones. Multiply that by 10, and I get 10,000. Now, many schools don't even have that many cubes in their school. So it's really hard to even show that to a student, but this really helps people understand the magnitude, how much 10,000 is. Multiply that by 10, you get 100,000. Multiply 100,000 by 10, and I get 1,000,000. And when I multiply that by 10, I get 10 million. And I love showing this to students because, again, if you look here, that girl is now standing beside 10 million. So she gets an idea, so your students get an idea how big, that million is that big, but 10 million would be that much. Multiply that by 10, and look at how many of those little 1 unit cubes are in that 100 million. There's 100 million of them. Multiply that by 10, and I get 1 billion. Now, here's an issue. Here's some disturbing research about base 10 blocks. In the earlier grades, we may have gone a little too fast with this unitizing. And so this here, 4 rods and 3 ones, kids could tell me that was 43. But if you ask kids, you break apart the tens and you tell the kids, well, what if I broke apart the tens? How many would I have? 2/3 of the students in grade 4 said, I don't know, I'd have to count them. That's really startling. This one here, when we hold the cube up, 1/3 of the kids in grades 6 and 7 in 2007, 1/3 of them said that is 600. And the reason they were saying that is 600 is it has 6 faces, and the cubes in the base 10 blocks are empty. And so they think that you just have to count the faces. So be careful. You want to make sure that your kids can answer those two questions. So, tasks for you. If I was to put a meter stick in front of you, so imagine this is a meter stick. This meter stick is divided up and it represents a billionaire. And what I want you to do is somewhere along the bottom of your screen, you should see something that like where there's, I think where you have the 3 dots. You should be able to find where it says annotate.
Annotate.
Yeah. And so if you were to click on the annotate, what I want you to do is get, you could either get the drawing tool and just draw. See how I'm just drawing on my screen? What I want you to do, and because this is very anonymous, your name will not show up on who's drawing. I want you to take, you could do an arrow. You can do, if I take the stamp and there's an arrow, I can use the arrow. Oh, nope, I don't know how to change it now. Undo. I want to, yeah, just use the drawing tool and show me where the millionaire would stand on this meter stick. So if that whole meter stick represents a billionaire, where's the millionaire? What you need to think about is how much bigger is a billion than a million? Can you find the arrow? Can you find the annotating tool? Anybody? No? Oh no. Come on, really?
Don't see it.
3 dots, it doesn't say annotate? Where it says more?
Trying to check. No.
Where it says, okay. Okay, then, oh, someone got it. Someone got it. Someone put a, oh, you have a crayon. Okay, use the crayon. Okay, so some of you are putting it right there. So before we go any further, I'm going to ask, what is $500 million? What is $500 million? $500 million. So
Yeah.
that would mean that this here in the middle, $500 million is 500 million. So 500 million is right in the middle. So think about this. If that's 500 million, I'm gonna, oops, that's my green arrow. That means that each one of these is 100 million, meaning this is here is 900 million, 800 million, 700 million, 600 million, 500 million, 400 million, 300 million, 200 million, 100 million. Well, where's the 1 million?
Yeah. Mm.
The 1 million is at the millimeter mark. Just to give you perspective of how big a billion is, it is 1,000 times bigger than a million. Yeah, William got it. You said a billion is 1,000 times greater than a million. So if you were to take your meter stick and divide it into 1,000 parts, you'd get to your millimeter. Half of a billion is 500 million. Okay, thanks, guys. So now, oh, no, clear. And now, there are some great online visualizers of how much Elon Musk is worth. Yeah. Okay, so now let's get to the decimals. So taking that knowledge of what you just did with 10 times greater, we're going to start talking about the decimal. And the decimal is a part of a whole. And so when we talk about decimal fractions, and I'm just going to, okay. A decimal fraction is a fraction where the denominator is a power of 10. It is such as a 10, 100, 1,000, etc. We can write decimal fractions with a decimal point and no denominator, which makes it easier to do calculations like addition or multiplication on fractions. Now, or what we can also do is, what we want to know is that every decimal fraction can be written two ways immediately. So here's what I want you to know right from the word go. If I was to put a number like, I would like you to write down $11.53. No, sorry. I'd like you to write the number $14.53. Now, when I'm talking about numbers like dollars and cents, there's a couple things I want you to know. One is I don't say 14.53. I just said $14.53. But when we jump too quickly to dollars and cents, some kids think that the decimal point separates two whole numbers. 14 is the dollars, 53 is the cents, but 53 cents is also the same thing as 53 pennies, which is a whole number. So we're going to talk about that in a second, but I just want you to know that we also don't want to use language that is just shows us like where the number is located. So what I'm saying is this. When I say the word 1/10, students should automatically, and so should we as adults, automatically know that I can write that as a decimal or as a fraction. If I say 100th, I should also know that I can write that as a decimal or as a fraction. 1,000th, I can write that as a decimal or a fraction. Now, those are unit numbers, and so we want kids to know that every single decimal can be written as a decimal or as a fraction immediately. So if I said something like 53 hundredths, I know my students should be able to write 53 hundredths as a decimal or as a fraction. Now, be very careful that you don't use positional language. And what I mean by positional language is this. I'm not going to say 0.1 or 1/10 or 0.001 or 1/100, 0.001 or 1/1000. And the reason I'm not going to do that, and if I was to go back to my classroom right now, that is one thing I would change immediately, is by doing that, we don't give any value to those digits. For example, if I'm talking about whole numbers, Like if I was to go back to that whole number that teacher put on the board of 5 billion. What was that number that I had up there? 5 billion, sorry, 5,036,407,004. If I taught my students and I only said 5036,407,004. Wow. That number has no value whatsoever. If I said the number like 842 instead of 842, I've given that number no value. I've just said digits. And so I'm not sure where we've gone wrong when we start with decimals and we start saying 0.1 or 0.01 or 0.453. We need to say it correctly. 453 thousandths. And if we say it correctly, now kids know that they can write it as a fraction or as a decimal. It is up to them, but they will realize that if I was to write it with decimal as a decimal, then I can do my operations and my computations a lot easier than doing computations with fractions. So the pattern is we extend the pattern in the way we write whole numbers to write decimals, and the place value system is extended to the right of the units place, not of the decimal place. There are numbers between every two consecutive whole numbers. The place value system can be extended to the right of the units place to show numbers between two whole numbers. And so, for example, to represent a number that's between two consecutive whole numbers, we first say the whole number, and we would say the smaller whole number followed by the part which is separated by the decimal point. For example, a number between 4 and 5 would be 4 and 67 hundredths. And so the digits to the right of the unit decrease in value in powers of 10. Each place value to the right of the units place is 10 times smaller. So we need to get those kids to move from whole number place value and unit fraction ideas to see that link between fractions and place value and the relationship between the places, not just the value of each place, not just that place value chart, not just the tenths, the hundredths, the thousandths. We want them to see that relationship. So here is that place, that trendsetter house. It's the ones, then we have the thousands, the millions, the billions, and then we place that decimal point. And that decimal point separates the whole numbers by the parts of the next whole number. And you will see that everything here now goes tenths, hundredths, thousands, 10,000s, 100,000s, and it keeps going as it is all based on this one. Everything is symmetrical to the one, not to that decimal point, but to the one. Going to the left, every place value is 10 times greater. Going to the right, every place value is 10 times smaller. So if I was to show a whole, it's 1. And now this is where we've really changed the life for our kids when we said that that flat used to be 100. And now I tell my kids, well, now all of a sudden it's a 1. And they go, well, Mrs. S, you said it used to be 100. How come all of a sudden it's 1? And my answer is because I'm the human. And this is a man-made object that we use to help us represent numbers. We give it a value. it doesn't tell us what it is. So I'm going to say this flat is now a 1. And now if I'm going to say if that's a 1, just like fractions, everything is compared to the 1. So if I was to divide that into tenth equal places, then each one of those would be a tenth. If I was to divide that tenth into ones, into 10, I would have hundredths. Or I could also say, and you can see the relationship of that whole divided by 100. Now I have hundredths. And the same thing if I was to look at the thousandths. Each one of those hundredths is divided into 10 to make 1,000. And so black and white, it's pretty simple. If you were to just use your grid paper and have kids, you could model, say, model 1/10 with a crayon, color in 1/100 of a 10 of 100, 10 by 10, color in 1,000. Or you could say, show me what 3 and 146 thousandths looks like. And kids could see, okay, now I see that 146 thousandths. Well, I can see that is also 1/10. It's also 4 hundredths and 6 thousandths. And all of a sudden, I can do that quicker if I was coloring it in. So I asked you to bring some, the photocopy that I sent you. And what I want you to do right now is take that a colored paper. Now I know that I gave you 2 different sizes of grid paper. One is the centimeter grid paper and one is half centimeter grid. You can use whatever grid paper you want. And what I want you to do is to cut a 10 by 10 square from the colored grid paper. Using that square, put the glue on the side of the paper that has the grid lines so that when you put it into the table that I gave you, the chart, the decimal chart, or the I can't remember what I called it in the paper I gave you. What I want you to do is put that in the ones. Glue it down in the ones. And then using the rest of your colored grid paper, make a model of the rest of this number. 1 and 1,111 10,000. So I'm going to give you a few minutes to do that right now. And in the chat, when you are done, would you just say done? And I will take it from there. So you have this chart paper. You have that grid paper. You have cut out a square that is 10 by 10. I told you take that and glue it down into the ones. So for example, I'll just give you a hint. You take it and you're going to glue it in there. And then what I'd like you to do is, using the rest of your grid paper, model the number 1 and 1,111 10,000. If I had some great music, I'd play you some music while you're doing this. Okay, Tara, think about this. What is the relationship of each place value? Remember, it is 10 times greater. So if you're stuck at the hundredth, after the hundredth, how would you make the thousand? Remember, it is, and I'll start it off for you. This is the 10th because it is, you've taken this one and you've divided it by 10. Now you have, this is a 10th. The hundredth was easy because you know that it's just one of those squares, but also the relationship is this is 1/10 of this here. So now in order to get the thousand, what would you do?
Divide by 10.
Exactly. Divide that by 10. It has to be 1/10 of the 100.
Mhm.
I should have brought my jeweler's loop.
Yeah.
Okay. And then how would you do the 10,000?
Well, divide by 10.
Divide that 1,000 by 10. And so it's a really tiny little piece. Now, some of you may have used the centimeter grid. Some of you may have used the half a centimeter grid. And the problem is when you got to the thousandth or 10,000, your pieces would have just been smaller, but it's still why I would like you to use both sizes in your classroom is to show the kids that part of the whole all depends on the size of the whole.
Mhm.
Just like fractions. Okay, now taking that, we can extend that activity into a way that we use decimals every single day by using money. So what I want you to do now is look at this, what I have displayed. What is the total of this? What do I have shown?
Oops, sorry.
Isabel, quit drawing on my screen.
I'm sorry. I'm going to erase that. Yep.
Okay, I'm kidding. What's the total? $1.11.
Yeah.
Yes? $1.11. So now what I'd like you to do is take your paper copy of your coins to model $1 and 111,000 of a dollar. So oh, William, I love it. I see that one eye. I wish I knew how to do that. But okay, if that's the dollar, what's 1/10 of a dollar?
10.
A 10 cent. Okay. Now, our government didn't do us any favors when they took away this next coin. What is 100th of a dollar?
And yeah.
1 cent or a penny.
Yeah, we really want to make sure our kids know when you get to dealing with money, you want to make sure kids understand that we used to have a penny and it's a very valuable coin. The only reason we don't have it anymore is the copper it used to be made costs more than a penny. So the Canadian government said we're not using it anymore, but it is it does show us, it's just like a place value blocks. It represents 100th of a dollar. But now, what would represent 1,000th of a dollar? How do we get what is 1,000th of a dollar? It is 10 times less than a penny, right?
So we
So
cut
we
it in
don't have
10.
a coin. So what we need to do is we need to take that penny, we need to divide it into 10 equal parts. And the same thing goes here, you guys, when we're talking about fractions. I say stay away from the circles for a long time because it's very, very hard for students and for us as adults to show that this is equal parts. We want to make sure that people know that this has to be an equal part. So what I'm talking about here is this 1/10 of that penny represents 1/1000th of a dollar. And I get people who say to me, who cares? Watch. I want kids to make sure that they can do 1 1/10 of a cent. And so I wouldn't go any further than that. Again, this is the penny. This is 1/10 of a penny, same thing. So now I can say, whoa, so are you telling me 1/10 of a cent is different than 1/10 of a dollar? You bet it is. And again, I still get adults that say to me, who cares? Well, I care because we see this every single day out in the real world. Where? William is shaking his head. William, where are
Gas.
gas prices? That gas price that is out there right now, I can't remember what it was. I think it was 1.32 and 9/10 of a cent. That 1.32 is 132 cents. 132 pennies. It's not $132. It is 132 cents and 9/10 of the next cent. So I get students that write this all the time. They put a dollar sign and a cent sign and a decimal. You can't do that because if you're using the dollar sign, then what I'm saying is that my whole is a dollar. If I'm using the cent sign, then what I'm saying is my whole is a cent. Because I've used that decimal, I'm saying that I'm showing you parts and wholes. So this is one of the things, this uncovers misunderstandings when I do the dollar and cent sign in one place. Now, I want to show you something that just blows my mind away. Verizon is a major data company, a telephone company in the United States. They quoted their people 0.002 of a cent per millibyte, but they charged their people 0.002 of a dollar per millibyte. Now, most consumers had no idea that there was a mistake. This gentleman that did this video, he called them, you can follow along with this video online, he called them a number of times, and Verizon said, don't know what you're talking about. Don't know what you're talking about. So this recording that I'm going to show you, he actually every time he went further up the ladder, he said, is it okay if I record? And they gave him permission because they believed that they were correct. So this is great. But before we go on, do you agree that 0.002 of a dollar is different than 0.002 of a cent? In the chat, yes or no?
Yeah.
Just one person saying yes? Okay.
It's the pen of your whole, 2,000 of the whole. That's
Right.
a big point.
Exactly.
Okay.
Okay, here we go. Listen to Verizon, a major corporation in the United States.
Looks like you're requesting some kilobyte usage that was done while in Canada, $0.002.
Do you recognize that there's actually,
0.002 cents.
yes, do you recognize there's a difference between those two numbers?
$0.002 and $0.002 cents.
Yes. Is there a difference between,
They're both the same if you look at them on paper.
And before we go on, again, do you see how saying that number 0.002? It
Mhm.
gives you no value to that number. And you're right. And what he's saying, yep, they're the same if you look at them on paper.
Why?
no, they're not actually.
So it's 0.002
Cents, remember, it's cents.
times 35,000. $71.79.
No, that would be 71 cents. How much should I be charged?
Calculated. 79 cents. Cents of a penny. On a kilobyte.
2/10 of, hold on. 2/10 of a penny would be 0.2 cents. You quoted me 0.002 cents. So which is the real rate?
0.002
0.002 what?
per kilobyte.
So you just said it was 0.2 pennies. And then you also said it's 0.002 cents. Those are two completely different numbers. They're 100-fold different.
Sure. Hold on 1 second for
Sure.
me, okay?
Oh, I love this
Do
conversation.
you recognize that there's a difference between $1 and 1 cent? Do you recognize there's a difference between half a dollar and half a cent? Then do you therefore recognize there's a difference between $0.002 and 0.002 cents? I'm teaching math here. And we're talking about cents, right?
0.002, if we multiply that by the amount of kilobyte usage that you have,
35893
35893, that comes out to what you pay, 71.79.
cents. You never did the conversion from cents to dollars. 0.002 cents times my 35,893 is a number, but it's still in cents.
We're not quoting $0.002. We're quoting $0.002.
Oh, God. Honestly.
Well, I mean, it's obviously a difference of opinion.
It's not opinion. Okay. Well, you know what? I'm going to post this recording on my blog. And
That's fine.
that's what I'm going to do. And then you guys all at Verizon can learn.
And that's where she hung up on him. And he posted this. And all of a sudden, Verizon got wind of it. And guess what they had to do? They had to pay people back their money.
Mhm.
Now, if it wasn't for him, people would still be paying and they couldn't care less. And so these are big corporations that were making these little errors and huge errors. And so we want to make sure that we are teaching our students to be able to think and reason about numbers. How big is a number? How small is a number? I love this. Just taking a hundredths chart and just changing it to show kids how this 100 chart can all of a sudden become a decimal chart. And we can use this to also add and subtract. And we could use Cuisenaire rods. Cuisenaire rods are great. They are fantastic for using, sorry, Lucy, I'm just going to give you something before you leave. That's okay. I'll send it to you, Lucy. Anyway, Cuisenaire rods, this great because they're all relational. You can use the orange as the 1, and then you can, when you use these, you can show that you can see that the shortest is the white and the longest is the orange. So you start off with using the orange as the 1 and saying then the white is 1/10. And it's just a beautiful way to compare sizes of things. So you name all the other rods from that. So for example, the red would be it's 2/10. The green is 3/10, and then the purple is 4/10, all the way up to the blue one where it's 9/10. And again, if I say the numbers properly, kids can see that they can write that number as a fraction or as a decimal. And then I can also use these for adding. And when they're adding, they can add, and they would use it comparing it to the whole, which is the orange. Again, some common misconceptions students might have is they may correctly identify the digit in the place, but they don't recognize the quantity it represents. For example, they may identify that the 2 and 5 in the tenths and hundredths place is an 8 and 25 hundredths, but they don't realize that the 2 represents 2/10, or the 5 represents 5 hundredths, or that it also represents 25 hundredths. They also may have that whole thing about believing that it's just a number, it's a decoration point, that decimal, that it separates the whole number from another whole number. So they think of it as dollars and cents. They have learned that it can represent fractions, but when you say something like, and in just saying positional language, 0.4, some kids think that represents 1/4. And that's why it's really important we say our numbers correctly, not just positional language. So 3, instead of saying 3.10, we say 3 and 10/10. It's the number after 3 and 9/10. They think that 3 and 10/10 is the number that comes after 3 and 9/10, whereas we know, thinking about this, if we had 10/10, it would be the next whole number. It would be 4. It wouldn't be 3 and 9/10. So there's some really good activities out there that you can use. One of the books that I love is Mind the Gap. And there's a grade 3 to 5 book or a grade 6 to 8 book. And these are questions that John Sangiovanni gives. For example, just something like this. You put two numbers, 38 and 39, and you put a dot and you say, what number would this dot be? Or a number like 81 and 81 and 2/10. Well, where would the dot be? Really great little questions like this, rather than just saying number and have kids numbering them themselves. These questions really make them think. Other things like from his book, explain how you know if the decimal is close to 0, a half, or a 1, and why. So for example, 97 hundredths, is that close to a 0, a 1, a half, or a 1? 44, 44 hundredths, 82 hundredths, 9 hundredths, etc. And so this will also help with rounding. What do you see? What do you notice with these two number lines? This is great. These are great. This is a great task to put up on your board. Well, both have, if I was to notice it, I noticed that there's 3 and 56 hundredths on both of the number lines. But what's missing?
The reference.
The endpoints are missing. And so ask them, what kind of endpoints do you think we could put on here? It really, both endpoints will be different. Or else a deeper, a higher level question, name 2 other decimals that can be found on the number line other than 3 and 56 hundredths. Now they really need to decide what those endpoints are. Okay, I'm not going to get into adding and subtracting, and I didn't think I would. I will do another session in November on adding and subtracting large and decimal numbers, but just to give you a quick idea, you could use if you're doing tenths, you could use your 10 frames, and this would be 3 and 2/10 plus 2 and 3/10. Really great, just to show that it really brings it to life for them. Or using your grid paper and do things like 6/10 plus 1300ths, and that they just color things in, and they would see that that's actually just equals 7300ths. You could do this one here. You can just draw color in yourself, and I would say this is 3/10 plus 300ths. What do I have? Well, that colors in 3300ths total. Just again, coloring things, those 100 charts in, is beautiful way of doing it with 2 different crayons and just showing, helping kids see how much it is. The second example is what happens when I color in 2 holes. Well, all of a sudden I have 7400ths and 8700ths, and I get 1 and 6100ths. So it's yes, Isabel, you had a question?
Yeah, do you have an app like this for that we can play on a board?
An app? Yeah, I do. I'll put that on the thing, on the sheet that I'm going to give you right away then.
Okay,
And
thank
then
you. That's
this is
okay.
another one for
Okay.
subtracting. All they do is they
Yeah.
color in what they're going, like for example, 5700ths minus 2200ths. And what they would do is you color in 5700ths first, and then you cross off 2200ths. And the squares that are left behind that are not colored are is the answer. So unfortunately, that is where I'm going to leave off, but I just want to give you hold on, in the chat. Sorry, here is a link to everything that I said I'd give you today, but now I will have to put in my slides. And then I will also add in an app for the 100 frame so that you can use this on your board, okay? I'll find that and I will send that, leave that in there for you. And unfortunately, that is all we can have time for, because it is 5:15. And so stay tuned for upcoming math sessions. I gave you at the bottom of that page where it says upcoming sessions, I will do the adding and subtracting session sometime in November for you if you wanted to join me. On that note, thank you very much for joining us today.
Thank you, Elena. That was awesome.
And I'll also put my email in here. Oh, you have my email because I sent you the thing. So thank you.
Thank you. Okay, I have a question, Elena.
Yeah, go for it.
When I'm going to close that session,